Page 492, number 27, and I'm just doing part A, asks us to find an algebraic method to find the polar coordinates of the point 1, 1 in the restriction of theta existing between 0 and 2 pi, so only one trip around the circle. So what we have to do is we have to find r and theta. So we're going to start by finding r, and r can be found by knowing that r squared equals x squared plus y squared. And since we have x and y, r squared is going to equal 1 squared plus 1 squared. So r squared equals 2. So r is going to equal plus or minus the square root of 2. So obviously we're going to have more than one way to represent this point, which is fine. So then we're going to use the idea that tangent of theta is equal to y over x. So theta is going to be the inverse tangent of y over x. So theta is going to equal inverse tangent of 1 over 1. So theta in the unit circle has two values, one that's going to go with the positive square root of 2 and the other one with the negative square root of 2. So we have pi over 4, and we also have 5 pi over 4. So now we can write two different polar coordinates for the same point, 1, 1. The first one is going to be square root of 2, comma, pi over 4. And the other one will be negative square root of 2, but we have to pull it back to the first quadrant, so that's where the 5 pi over 4 would come into play. And those will be the polar coordinates for the point 1, 1 in one trip around the circle.